this line is executed. Okay, for this line to execute, since we are writing our own vector class, what this means is like we should write a constructor, because we are constructing an object called v2 of vector of ins, which takes in as an argument another vector, another object of the same type. And so we should write a copy constructor for this code to work properly. And then what we do here is like print vector v2, and we try to actually change the value of the vector. So if you see here, the code starts like this. Okay, this is printed from inside the default constructor. So this is like v1, and then this is printed from inside the copy constructor. So when this line is executed, when line 20 is executed, the line copy constructor is printed, and then in the next line we just print v2, which is just a copy of v1, exact copy, and then we go ahead and modify one element, the first element in v2 to be 4. And after modifying that, we are printing v2 once, which is 4, 2, 3 now, and we are printing v1 again, which is 1, 2, 3, which does not get changed. Okay, but if we don't have our own copy constructor, which is here, okay, copy constructor is here, which just says go and copy the capacity. Just to give a view, we have like elements pointer to type t, then we have capacity, we have size. Okay, and so this just says copy the capacity from the other vector, copy the size from the other vector, and for the elements just don't copy the vector value, sorry, the pointer value. If you just copy the pointer value, both v1 and v2 will be pointing to the same dynamically allocated memory on the heap. And so changing one vector will also affect the other vector, and so to avoid that, we are creating a new vector here inside the copy constructor. For this particular vector, we are creating a new vector, we are allocating new memory on the heap and having elements of this particular vector to point there. Okay, and then inside the for loop, we go and just copy all the elements like one by one from the other vector. This is what a copy constructor does. Any questions about this? Yeah.
How do you get the size and capacity of the other if they're private? How does that work?
That's a very good question. So the question is, how do we get the capacity and the size of other, since it is a private variable? So even though it's a private variable, this particular copy constructor is a member function of your own class. Since it's a member function, it's just a constructor, right? So since it's a member function, public member function of your own class, we can access all the private data members.
For the other one? For the other vector?
Yeah, that's like, since a class, okay, from within a class, you can access the same class's objects, private data members directly. It is like, it is allowed. Yeah, that's actually a very good point to note. If you see here, even though this is a member function, you can directly access the size and the capacity of this vector. That is fine. You can say like this dot size, this dot capacity, but also, okay, it is allowed to access the private variables of the other vector only if the other is a object of your own class. Only if other is an object of your own class. You cannot like say, you cannot, if other was some other object of some other class, you cannot access the private data members of that particular class in any constructor or in anything. Okay, so since this is a member of the same class, you can do this. Okay. Now the next thing that we are going to try is, in a similar way, just copy this whole code here and make this like v3. Okay, we are just creating a vector called v3, and v3 is nothing but we are assigning the value of v1 to v3. This assignment actually again should be a copy assignment, because we are creating a new vector called v3 with the exact contents of v1, and then we will go and try printing v3. Then we will change an element, the first element in v3 to be, let's say, 7, and then we will print v3 again and v1 again. Okay, this is the thing that we are doing here. So when you just like execute this, okay, that is like some error which we saw in last class already, that the same memory is being freed twice. Okay, and the reason is, if you see here, if you just check here, we print v3 after making a copy. Okay, and then we change the first element in v3 and then print v3 here, and in the next line if we print V1, V1 should not have been modified because this assignment just means that, okay, copy the elements from V1 and form and have it as the same elements in V3. But this should have been 1, 2, 3. The same V1 should have been printed here, but that is not what is printed here. And the reason is, again, both these things, if we don't write our own, if we don't overload this operator for classes in which we are managing memory by ourselves, okay, again, this is an issue, very similar to the copy constructor. If you don't overload the assignment operator, it is an issue because both these objects, V1 and V3, are pointing to the same dynamic memory at this point, okay. And so, to avoid this, we go and we write our own assignment operator, okay. So, we are going to write our assignment operator, and it's going to be operator equals, we are just overloading the assignment operator for this particular type, and we are getting in a const, another vector as the argument, which is the right hand side. Get it by like reference, the other vector. And as of now, we don't know the return type, we can just have it as void, okay, and maybe change it later. And this assignment operator, to start with this assignment operator, we can just copy the code that we have in our copy constructor and start from there because it's very similar. We're just trying to make a copy. But if you just copy this code here, there are like some issues, okay? In assignment operator, what is happening is when we start here, okay? When we start a vector of V3 here, this would have called the default constructor, and when the default constructor would have been called, automatically we would have got some elements here. So see here, there is some elements, this pointer has been initialized and some memory has been already allocated with the capacity of 16 because that is the initial size, okay, the capacity of 16. So size for 16 ints have already been allocated for V3, and then when you do V3 is equal to V1, then at this point, if we just create a new vector here, then immediately what will happen is, at this point? So when this copy assignment is called, okay, this elements is already pointing to a 16 element array on the heap, and when that is happening, if you just say element is equal to new d of capacity, then there is a memory leak. That 16 elements that we already allocated is actually lost. We have not deleted that element explicitly. So in the copy assignment operator, before like creating the new vector, first you should delete. You should delete elements, wherever the memory that it is pointing to, delete that entire array that it was previously pointing to, and then create a new d of capacity, okay? Because now you have copied this capacity from the other capacity, and so it should be fine. Just create a new d of capacity and then go and copy elements one by one, okay? Does this make sense? Why are we deleting the old thing? Because the object has been already, in this case, when we are creating a copy constructor, directly the copy constructor is called, and so there's no memory that is associated with V2. But in the other case here, in this line 26, allocates a memory for V3 already on the heap. And so when we are doing this line, before copying contents from V1, we should delete that particular memory that V3 already has, and then go and copy contents or like create a new dynamic array on the heap and then copy the elements from V1 to V3. And there is an issue here, okay? What will happen if we write a statement like V3 is equal to V3, okay? This is a valid statement, valid C++ statement. If we do like a self-assignment, in this case, what is going to happen is, here the other vector and this vector both will be the same, and so in that case when we go inside here, there will be like, okay, capacity will be copied, size will be copied, you would have deleted the elements here. So now when we have deleted the elements, okay, sorry, there is a mistake here. Since we are just like Yeah. Yeah. I don't think that's okay. So you have deleted the elements here, which means that you have actually deleted other dot elements also. So whatever the others memory, other vectors memory on the heap is now deleted because both are like v3 is equal to v3. And so in that case, since the other vectors memory is also deleted on the heap, so now what will happen here is when you go and try to access other dot elements of I, okay, this memory is now deleted, it is free. And so now this memory is not even there. When you go and try to access that memory, then it will be a segmentation fault. And so in copy assignment operator, initially before even doing anything, you should first do a check if this and other are the same. So what I am exactly doing here is like this is a pointer, okay, this is a pointer to the current object and other is the other object that is coming here, and if they are not equal, so there should be, if this which is like the object that we are calling this method on is not equal to the address of the other vector that we are passing in, if these are two different vectors, then execute this code, else do nothing. Okay. So these are just two changes that we want to make from the copy constructor to make it the assignment operator. And once this is done, even though this is done, so now think about cases like what will happen if someone writes v1 equals v2 is equal to v3. This is valid code. Okay, we can do something like this, where both v3 and v2, these two vectors will get the value, will be exactly equal to whatever v1 is. But in our current code, okay, we have the return type as void, and so this will not work. So instead of it being void, here you should just like return whatever, after changing this pointer, you should just return that particular object. Okay, you should just return this, start this, because since this is a pointer to the current object, you will return the actual object itself. And since you are returning the object, usually we will return objects by reference, and so you will just say vector ampersand here. So now operator equals, which is the overloaded assignment operator, returns vector ampersand, okay, which is a reference to a vector, and so we are returning star this. Now in this code will work because now first v2 equal to v1 will get executed, and that would have returned a vector. And now that vector would be used as the right hand side, and that would be assigned to v3. Okay, this is very similar to the plus equals operator that we studied. Like why do we return by reference? That's like very similar. Okay, any questions about this? So now let's try the same thing that we did. v3 equals v1 and see what's happening. Yeah. So now if you see here. v3, then the copy, and then we just change the first element in v3. Now 1 has been changed to 7, and then we print v1 again. v1 is unchanged. So now our copy assignment, this is also a special member function, even though this is just an operator overloading. Okay, this is a special member function called the copy assignment operator. Okay, this is a special member function called the copy assignment operator, and whenever, if you are managing some resource in your class that you're writing, for example, in this vector class, we are managing the memory by ourselves. Whenever you're doing something like this, then what will happen is, in your constructor, okay, usually in your constructor, you will acquire that particular resource, which is here. Okay, if you see here in your constructor, we are acquiring memory, we are like creating some memory and having a pointer to it. And in the destructor, you will actually release that particular memory. In our destructor, which is here, you will actually delete that particular memory. So whenever you are actually acquiring some memory in the constructor and deleting in the destructor, that means that you are actually writing a destructor, right? So whenever you write a destructor, then automatically it means that you should also write your own copy constructor and your assignment operator. So if you write a destructor in your class, okay, then it means that we are managing memory by ourselves. So in that case, for sure you should write the copy constructor and the copy assignment operator also. So these three things come together, and this is called rule of 3. Okay, this is just called rule of 3. So whenever you write a destructor, or whenever you write any of the other two, it means that these three things come together in a bunch. Okay, so it is most likely that you will need the other two also, so go and implement the other two, else you are making some mistake there. Think about the matrix class that we wrote. In the matrix class, we did not write a destructor because the elements were, we were using vector there, okay, as the private data members. And since vector is a class that manages memory by itself, okay, when we were writing the matrix class, we need not worry about managing memory manually. And so we did not write a destructor. And since if we don't have a pointer, okay, or like a file handle in your as one of your private members, then it means that you are not actually managing memory by yourself. In that case, you don't need any of these destructors, copy constructors, or copy assignment operators, and that particular thing is called rule of zero. Okay, rule of zero. You don't need any of those things. And in modern C++, we will be managing memory only when we are writing some library code. Like if we are writing a container like a vector, we will be managing memory by ourselves manually. Else, most of the time you will be just using rule of zero, where you will be using the standard libraries, containers like vector, map, sets, and everything, which will manage memory for you. And so you need not worry about writing any of these three special functions called destructor, copy constructor, or copy assignment operator. Okay, that's called rule of zero. And whenever a class acquires a resource, okay, or acquires a resource in the constructor, very similar to what our vector is doing right now, and releases that particular resource where we delete the memory in the destructor, this particular idiom is called RAII, which is called resource acquisition is initialization. Whenever you acquire a resource, okay, the resource acquisition just happens whenever an object of this class is initialized. The resource acquisition of this particular vector happens, let's say in our main, it happens in this line. In V1, the resource is acquired for the particular vector, which is like 16 elements on the heap. And when will this vector memory be deallocated is whenever the destructor of this particular vector is called. And so when the destructor of this particular vector will be called, so this delete elements will be executed and it will be deleted. And when will this be called? When V1 goes out of scope. V1 here is just a stack object, okay? A stack object on this particular main stack frame. So when we come here, the destructor is called here, and V1 will go out of scope. And why 3 destructors is called? Because we have like 3 different vectors, V1, V2 and V3. 3 of those vectors are deleted separately. And whenever this happens, the memory is automatically deallocated, and this particular form of managing memory is called resource acquisition disinitialization. It's a very bad name actually, given to a very good idea in C++, okay? And you can think of it as the constructor acquires and the destructor releases. This is one other name, and one more name is like scope-based resource management. And this was the only reason why, even though when we were opening we were creating input files, right? When we were creating input files, you would just say ifstream in file, just give the file name there, and don't even worry about closing the file in C++. Because that ifstream class in turn handles that file object for you. Okay? And whenever that in file object that we are creating on the stack goes out of scope, then immediately the destructor of that ifstream, the input file stream, will be called, and that particular file will be closed. And you can see this idiom like in so many places in C++, and yeah, you need not worry about actually, and the same thing happens with smart pointers also. Whenever we are using smart pointers, why don't we actually delete the memory manually by ourselves? Because the destructor of the smart pointer takes care of that particular memory management for us. Okay? And yeah, this is all about rule of 0, rule of 3, and RAII, the resource acquisition initialization. Okay, and in the last few minutes that we have, any questions about this, about rule of 3 or RAII? Whenever you just come across these terms, just try to like go and refresh your memory about what that is, then I think everything makes sense. But for understanding RAII, the basis is just to understand how do we manage memory by ourselves. in a class like vector, and that happens in many other classes, and that particular idiom is just called RAII. There will be so many fancy terms like this in C++. Don't immediately think like maybe you don't know those things. If you just go into the details of some of those things, it will be very easy. If you understand the basics of whatever is happening, then you will be easily able to understand whatever is built on top of that. And one more thing is like whatever we have covered in this particular semester, according to me, we have just scratched the surface of C++. Okay, even though we have covered like so many modern things. Okay, I would say like we did not even study, like we did not even reach like 10% of what C++ is. Okay, I'm sorry to disappoint you guys, but yeah, C++ is such a huge language. And but what we have tried, what my goal for this class was from the beginning, is to give you an idea of like how to learn C++ by yourself. In the sense, after, because I was very sure like within this 15 lectures that we have, I would not be able to teach like entire C++ to you, but it's more like if you have understanding of many of the basic things, then you'll be able to like learn C++ by yourself whenever and to whatever level you need based on the type of work that you're going to do with C++. And so now we have like the course evaluations for the next let's take 5 minutes. But I just have like some tips on becoming a good C++ programmer. So I think okay, maybe I will just go through these tips right now, and then I will maybe let you guys fill the course evaluations when Varun and me will be outside the class at the time. Okay. So just like tips to become a good C++ programmer. And after this, if you are wondering like how can you like better your skills in C++, definitely go and get this book. This would be a huge leap in like helping you become a better C++ programmer. This is like Effective C++ by Scott Meyers, and there are like 2 to 3 versions of the book, which is for Effective Modern C++. But I think this is the best place to start. And if you read this book, with whatever we have learned in this class, everything will make sense, because this is not a book for the beginner, but this is a book for like a person like you guys right now who know like the basics of C++ and who can build on top of that. So if you want to like get into more details, do that. CPP reference, according to me, one of the best. I would say like this is one of the places where I personally learned C++, modern C++ by myself, and definitely refer this, start reading this. Okay, once you get very comfortable with CPP reference, it will be like you will be like doing a great job in C++. And there is a YouTube channel called CPPCon. Okay, it's just CPP. There is a CPP conference that will happen, and they have like all the videos posted. If you want to get some deeper understanding of like how to learn C++, go and look at those videos. There will be just a video on vectors, or like just a video on smart pointers, like that. And even one of the videos here, while I was doing some research about how to change this class completely, in the CS department gave me a challenge. This was the place where I started. I saw like there was a video on like how to teach modern C++ by a person called K. Gregory, and that was like really useful in designing this particular class. So this is like a very awesome YouTube channel. And also, this is one of the things that I always tell about my classes: learn from friends. Whoever knows C++ very well among you, just try talking with them, understanding many stuff there. Okay. And always be a humble programmer. Okay, this is just a piece of advice. Even though you now you have learned C++ and you know Java and all those things, it's fine. But whenever most of the best programmers that I have worked with are actually always like very humble, so that you can actually go and talk with them anytime you want, like learn so many stuff from them. Just don't be like the person who, if someone comes and asks you, like, hey, can you explain me about this? Just don't give them a look like, oh, you don't even know this, or something like that, okay? Just like don't do something like that. And yeah, we just, so in the course evaluations that you're going to fill out right now, the main thing that we want to like understand from you guys is how effective was the changed curriculum, or like the syllabus. We completely changed the syllabus, and along with that we also changed the order of topics. If you really want to understand how it was before, just go and search CS 368, okay? This was the previous Spring 2016's version of the course, and in the syllabus, see the topics here, okay? there will be like constants, enums, structs, arrays, then pointers, arrays, dynamic allocation, then reference variables, .h and .cpp files, make files, big 3 comes here, operator overloading, file IO, and the last two classes they went into like templated functions and classes, and the last class went into iterators, generic algorithms, and function objects. Just look at this. Just this one lecture is actually so important, and this was made like 1/3 of the course this time. Do you understand what has just happened? This one lecture that they have given about the standard language here was the 1/3 of the lecture that we have right now. The orange color section that we have about vectors, maps, because that is what we will be using there. This was the main change that happened, and then we also changed like what to say, how do we deal about like let's say the rule of 3. We wanted to introduce that only when the need arose. The need only arose when we want to implement our own vector class, and that was the time when we want to implement that. When I actually started learning C++, I even remember on the 3rd class they talked about destructor, copy constructor, assignment operator, and I had no idea what was going on. Just remember, if the topic, whatever we learned just today was taught in the 3rd class of the lecture. That was how I learned C++, which is like a really bad way. Yeah. And so we really want to understand from you guys how this modified curriculum or like modified syllabus worked for you, and how effective were both like Varun and me as instructors in this class. Okay. So please go right now. Okay. We'll be going outside the class right now, and we'll be waiting there. If you want to talk with us about anything, please feel free to come and talk with us. Please write whatever you felt about the course. Okay, in this you can go to aefas.biz.edu, or you would have received an email about the same. If you just search for course evaluations in your email, that will be direct link, or if you just go here, you can go to CS368 C++ and start filling out the things. It should not take more than 5 minutes. Please take some time to fill out, because based on your evaluations, the department is going to see if we want to like continue the course as I have changed it this semester, or maybe just like fall back to the way where we will be teaching more of C and very less of C++. Okay. And yeah, you can start writing the like course evaluations, and both Varun and me will be waiting out. And also, I think you would have realized like how much effort goes into like changing a class and like actually teaching it in a modified way. And usually at the end of every class, it makes me happy if you guys, if you personally have learned something from this class and want to do some personal feedback, please like write it in a sheet of paper. Okay, whatever you felt about the class. This is aside of the course evaluation. This is just for me. Okay, please write it in a separate like paper, like 2 to 3 lines, like a note about whatever you felt, and just you can hand it over to me if you feel so, and we'll be waiting outside. Okay.